We're back again. This is the third energy video, this time on conservation of energy and efficiency. So the last video we looked at was energy pathways and energy transfers, and we said that in a situation you start off with one type of energy, you end up with a different type of energy, and in between something happens to cause that energy transfer. This time we're looking at this idea about conservation of energy, and conservation is something that you will have seen in the other areas of science. It's covered in biology, it's covered in chemistry, and essentially conservation just means to keep the same. So in biology, when we are doing conservation, we are trying to stop animals and plants from becoming extinct. We're trying to keep their numbers the same, or perhaps improve them a little bit. In chemistry, we talk about conservation of mass, and that just basically means that if you start off an experiment with 100 grams of chemicals, you're going to end up with 100 grams of chemicals at the end. The amount of chemicals stays the same. In physics, we talk about conservation of energy, and it's exactly as you might expect. Conservation of energy just means that the amount of energy you have at the start of a situation will be there at the end. So again, trying to give examples. Just stick that up there. We're going with the example we looked at on the last video. So this was lifting the ball. So we've started off again, just to recap, with a chemical store in our muscles. Something's happened, the person's picked the ball up, and we've ended up with a gravitational potential energy store in the ball. In between, we've got this chemical reaction, which is the energy pathway. So we've started off with this type of energy, we've ended up with this type of energy, and the energy pathway is what's taken place to cause that energy transfer. In terms of this one, I've just given two numbers. So 100 I've just picked out of there simply because it's an easy number to deal with, and we start off with 100 joules therefore of chemical energy, and we've ended up with 90 joules worth of gravitational potential energy. So that implies that there's missing energy. Some energy has disappeared. We've started off with 100 joules, we've ended up with 90 joules. So does this happen? Well, no, because as I said, conservation of energy means the energy you have at the start, you have to have in the end. So this isn't right. So if you look at a different diagram, this actually tells us a more accurate picture. So we've got the first part, which we already have, 100 joules of chemical energy transferred into 90 joules of gravitational energy, but what will also happen is there will be another energy transfer. Some of the energy that we've started off with will actually be transferred into thermal energy, and that's just how your muscles work. If you do any sort of exercise, you ride a bike, you go out and play tennis, anything like that, your muscles waste thermal energy. Sometimes it's not a waste, we use that energy to keep warm, but in this case, because the person was picking up the ball, the useful energy transfer is the gravitational energy. We wanted that energy, we wanted to pick the ball up. The thermal energy is the wasted energy. We didn't want that. So we've got this idea of useful energy and wasted energy. And every single situation you have, every single energy transfer, there is bound to be, or virtually every single one, there is bound to be some wasted energy. So that gives us this definition, which is a bit smaller, so I'll use this one. So conservation of energy basically means energy cannot be created or destroyed. I cannot pull energy out of thin air. It has to have been supplied by some other means, and I can't just get rid of it. It will not disappear. The energy I start off with is the energy I end up with. It's just moved from one place to another, or one form or one store to another. So very quickly, I started off with chemical energy. I've still got the same amount of energy in total, it's just in a different place. Some energy is in the ball, stored as gravitational, some energy is in the surroundings, stored as heat, but the same amount is at the end compared to at the beginning. Now what that means is we have another idea now, this idea of efficiency. And again, efficiency is something you come across no doubt in maths, it's something you come across in biology, it's something you'll come across in chemistry. In this situation, we're talking about energy efficiency, and energy efficiency is a measurement of how good an appliance is at taking its input energy, the energy it was given, and turning it into useful energy stores. So an efficient appliance will waste less energy compared to an inefficient appliance. So an easy thing that you'll probably have seen are light bulbs. So in my day, light bulbs were filament light bulbs. If you search on the internet, you'll see them. You'll probably have them around your house. They work by getting hot, but their job is to get light. So we lose a lot of energy because they're wasting this heat energy. An energy efficient light bulb will waste less energy, so it won't get as hot. It'll give out more light energy. Now, I've just thrown this last bit in. It's assuming the same input energy. At foundation level, if an exam question asks you, why is this appliance better? And you say, because it wastes less energy, you're going to get the marks. If higher level, it tends sometimes not to be quite so straightforward. For example, if you have an appliance that is given 1,000 joules and you compare it to an appliance that's given 1,000,000 joules, well, the one that's given 1,000,000 joules will probably waste more energy, even though it might be more efficient. That might be going straight over people's heads. If it does, please just forget about it. Just go with this idea: efficient appliances waste less energy. I'm not going to go through any calculations. I'm just going to give you the formula. Again, remember, an efficiency, or in an energy efficiency, the answer that you come out with must always be less than 100%. Certainly not more than 100%. Because if you end up with an answer that's more than 100%, you will have effectively created energy, which can't happen. So you always must have an efficiency of less than 100%. If you do your calculation and you come up with an answer that's more than 100%, you've got your numbers in the wrong way around. Quite often they won't give you this formula. So you'll have to either put the numbers in one way. If it doesn't give you the right answer, flip the numbers around, and that will probably be the right way. To say, I'm not going to give any examples of that. You can just write that down and have a go from the booklet. I'm sure there'll be some questions there. What does that mean? Why? So what? How is this relevant to you in your everyday lives? Well, if you look at most appliances, you go to somewhere like Curry's PC World or anything like that, a lot of the appliances, fridge freezers, televisions, hoovers, hairdryers, will have these stickers on them. And these are energy efficiency ratings. So you tend to have 1, 2, 3, 7 or so categories, A being the best, I would have thought, G being the worst. And it's all down to the efficiency of the appliance. An efficient appliance will have a higher rating. And that means they lose or they waste less energy. Now, that's good for a number of reasons. First of all, it's good on your pocket, because if you have something that wastes less energy, you are going to be spending less money. Energy costs money. Electricity costs money. If you are wasting energy, you are effectively wasting money. So an efficient appliance will save you money. It also has an impact on the environment, because electricity is generated, for the most part, through burning fossil fuels. If you waste energy, you are effectively burning fossil fuels for no reason, and that causes pollution. So 2 reasons why you want an efficient light bulb, why you want an efficient television, why would you want an efficient washing machine, is, first of all, it saves you money. It saves you money because you are wasting less energy, and it also saves the environment. It saves the environment because you are not burning fossil fuels for no reason.